Hi everyone. In the previous session, we have discussed about the model analysis and different dimensionless number and different model laws. Okay. So based on that, in this session, we'll discuss the problems on the model laws. Okay. So here, out of 5 model laws, I have taken 2 model laws. That is, one is the Reynolds model law, another one is Froude's model law. Because the most of the problems will comprises of these 2 laws. Okay, so I'll discuss the problems on Reynolds model law first. Okay, so you should remember what is the equation we use for Reynolds model law, that is rho VL divided by mu. That is the equation of the Reynolds number. Okay. This is the first problem. A pipe of diameter 1.5 meter is required to transport the oil of specific gravity 0.9 and viscosity 3 into 10 to the power of minus 2 poise at a rate of 3000 liters per second. Tests were conducted on a 15 centimeter diameter pipe using water at 20 degrees Celsius. Find the velocity and rate of flow in the model. Viscosity of water at 20 degrees Celsius is 0.01 poise. Okay. See, in this question, you have to observe clearly that what are the data they have given for the prototype and what are the data they have given for model. Okay, so both the data will be given. You have to see carefully. So, and you have to enter the data. See here, a pipe of diameter 1.5 meter is required to transport the oil of specific gravity 0.9 and the viscosity 3 into 10 power minus 2 poise at a rate of. Okay, tests were conducted on 15 centimeter diameter pipe, means this 15 centimeter diameter pipe is a model, 1.5 meter diameter pipe is a prototype. Okay, see, you have to divide your page into 2. Okay, first you write down on the left side, you write the values of prototype. In the right side, you write the what are the values or the details given for the model. Correct. See here, you observe this one. Here you have given diameter. Okay. There, that is diameter of prototype is equal to LP. Why you have used LP? Because in the formula we are having L. Okay. So L indicates it's any physical quantity which is having a dimension meter. Here the diameter is given, therefore DP will be acting as LP. So DP is equal to 1.5 meter. Similarly, here you can write what is the diameter of the model, 15 centimeter, that is 0.15 meter. Then yes, given, you have to find the velocity of the model, that is Vm as the question mark, rate of flow in the model. Rate of flow means discharge, that is Qm is equal to the question mark. And here the specific gravity is given, that is for the prototype, that is S is equal to 0.9. Viscosity is given, that is mu of the prototype, it is 3 into 10 to the power of minus 2 poise he has given. You have to convert that into Newton second per meter square. It becomes 3 into 10 power minus 2 into 0.1 Newton second per meter square, because be careful, all the units should be in SI unit only. Okay, so afterwards, here he has given the flow rate of 3000 liters per second for the prototype, that is discharge value, it is QP, that is QP is equal to 3000 liters per second. Here the SI unit of discharge is meter cube per second, divided by 1000. 3000 divided by 1000 is 3 meter cube per second. Once the discharge is given, you know the diameter of the pipe, you can find out the what is the area of the pipe. Once you find the area of the pipe, you use the basic relationship, that is velocity of the prototype is equal to discharge divided by area, because discharge is equal to area into velocity. What is the discharge value of prototype? 3. What is area? You know the diameter, pi d square divided by 4, pi into 1.5 square by 4, you will get the velocity of prototype. Here you have to find velocity of the model, discharge of the model. Here the viscosity is not same. Viscosity of the model is 0.01 poise. Mu m is equal to 0.01 into 10.1, 0.001 Newton second per meter square. We are converting into SI unit. Then you write Reynolds model of the prototype is equal to the Reynolds number of the model. Therefore, rho p, LP, Vp divided by mu p is equal to rho m, Lm, Vm by mu m. Be careful, LP stands for diameter here because the unit is meter. Lm stands for diameter of the model. So what is rho? What is the density? Instead of density, he has given the specific gravity as 0.9. Okay, it is the liquid is water. Therefore, the density becomes 0.9 into 1000. Okay, so it is 0.9 into, sorry, it is an oil of specific gravity 0.9, then the specific gravity of oil is given means the density of oil rho p is equal to 0.9 into 1000, because 1000 is the density of water. Therefore 0.9 into 1000 is 900 kg per meter cube. That is rho p 900. LP means the diameter of prototype 1.5. VP is the velocity we have found out here, 1.69 divided by the viscosity, which is equal to rho m. The density of the model is, the model we are using water. Using water he has given, be careful. So it is 1000, because density of water is 1000 into 0.15 into Vm is the velocity of model, it is unknown. So velocity of model is 5.091. So we have found out one quantity. He has also asked the flow rate. Flow rate means discharge. Discharge of model is equal to velocity multiplied by area of the model. So velocity is 5.091 into area is pi d square by 4, pi into 0.15 square divided by 4, you get the discharge. Okay, now you got the point that first you have to write the given data of the prototype as well as the model in side by side. Afterwards, you write the formula, you find out the unknown quantity, that's it. So water is flowing through a pipe of diameter 30 centimeter at a velocity 4 meter per second. Find the velocity of oil flowing in another pipe of diameter 10 centimeter. If the condition of dynamic similarity is satisfied between the two pipes, the viscosity of water and oil is given as 0.01 poise and 0.025 poise. Take specific gravity of oil is equal to 0.8. Here water is flowing through a pipe of diameter 30 centimeter, means the higher number always indicates the prototype, the lower number always indicates the model. So diameter of the prototype is 30 centimeter, it is 0.3 meter. Velocity of the prototype Vp is equal to 4 meter per second. Okay. So he has given, and also the viscosity of water and oil means, so in the prototype you are using the water, in the model you are using the oil, therefore mu P is equal to 0.01 poise, 0.01 into 0.1. Density of water, that is rho P is 1000 kg per meter cube. Similarly, model, here the diameter of the model is 10 centimeter. Then the viscosity of the oil, it is the water oil, that is 0.025 poise mu m. Rho P is the density of the oil. Density of the oil, he has given specific gravity as 0.8. 0.8 multiplied by 1000, you get 800 kg per meter cube. So again, you write the formula rho p LP Vp by mu p is equal to rho m Lm Vm by mu m. You substitute all the values. The unknown value is velocity of the model. Look at the question, what he has asked. He has asked find the velocity. So Vm is 37.5 meter per second. Next, problem 3. The ratio of length of the submarine and its model is 30:1. It is length, not lengths. Okay, make a correction here. Okay. Just you make a correction. So that is not length, that is length. Okay. The ratio of length of the submarine and its model is 30:1. The speed of the submarine is 10 meter per second. The model is to be tested in a wind tunnel. Find the speed of air in the wind tunnel. Also determine the ratio of drag force between the model and prototype. Take the value of kinematic viscosity for seawater and air as 0.012 Stokes and 0.016 Stokes respectively. The density for seawater and air is given as 1030 kg per meter cube and 1.24 kg per meter cube respectively. So here, first you have to find out what are the unknown quantities by using the Reynolds number. Afterwards, you have to find the drag force. So first we'll finish the first part. The ratio of length of the submarine and its model is 30:1. Means the ratio of length of submarine and its model, that is LP divided by LM is equal to 30 divided by 1. LP divided by LM is equal to 30. Therefore, LP is equal to 30 meter, LM is equal to 1 meter. Correct? It is a ratio, the ratio of the length of the prototype and its model, that is LP divided by LM is equal to 30. Therefore, LP is equal to 30, LM is equal to 1. That is what we have written. So length he has given. Then the velocity of the prototype means the velocity of the submarine. Submarine is 10 meter per second, that is Vp is 10 meter per second. And he has also given kinematic viscosity for seawater, because the prototype submarine he has taken as seawater. For it is tested in the laboratory, means they have used air. So therefore the kinematic viscosity for seawater, that is mu p is equal to 0.012 strokes. So 1 strokes is equal to 10 to the power of minus 4 meter square per second. Therefore it is 0.012 into 10 to the power of minus 4 meter square per second. It is meter square per second it is. Then the density of the prototype is density of seawater is given as 1030 kg per meter cube. Similarly, model length of the model is 1 meter. Then the kinematic viscosity for air is 0.016 strokes. That is 0.016 into 10 to the power of minus 4 meter square per second, because it should be in SI unit. Density of the model is given as 1.24 kg per meter cube. Then you use the Reynolds model law, you apply, and here the density is not given, viscosity is not given. Instead, sorry, here the viscosity is not given. Instead, he has given kinematic viscosity. Okay, not dynamic viscosity. He has given kinematic viscosity. Okay, most of the people you confuse with this. So what you'll do is, the viscosity is given, simply you blindly substitute the value of viscosity here. It is wrong. Okay, so here whenever the kinematic viscosity is given, you take the density to the denominator. It becomes Vp Lp divided by mu p divided by rho. Similarly, Vm Lm divided by mu m by rho m. I have taken this rho p and rho m to the denominator. Why? Means because we know that kinematic viscosity is equal to dynamic viscosity divided by density. Correct? So kinematic viscosity is equal to dynamic viscosity divided by density. Since dynamic viscosity is not given, kinematic viscosity is given. That's why this alteration have to do. So Vp Lp by nu p is equal to Vm Lm by nu m. It becomes 10 into 30, that is velocity and the length, divided by the kinematic viscosity is equal to Vm into 1 divided by kinematic viscosity. You get the Vm as 400 meter per second. Also, he has asked you to find the speed of air in the wind tunnel, and also determine the ratio of drag force. Yes, drag force means it is the inertia force only. Fp, that is force in the prototype divided by force in the model, is equal to, what is the formula for inertia force? Rho a v square, that is rho p ap vp square divided by rho m am vm square. Here area is not given, instead he has given length. I'll convert this area as lp square. This already we have discussed in the last session. So rho p lp square into vp square divided by rho m lm square into vm square. Correct? Therefore fp by fm, substitute all the values, density, length, velocity, you get the ratio of 467.22. Okay. Similarly, the fourth problem is, a ship 300 meter long moves in seawater whose density is 1030 kg per meter cube. A 1:100 model of this ship is to be tested in a wind tunnel. The velocity of air in the wind tunnel around the model is 30 meter per second and resistance of the model is 60 Newton. Find the velocity of the ship in seawater, also resistance of the ship in seawater. Density of air is given as 1.24 kg per meter cube. Take kinematic viscosity of seawater and air as 0.012 strokes and 0.018 strokes as well. It's similar to the previous problem, no change at all. Here a 1:100 model means it is when Lm is equal to, a ship of 300 meter long he has given. So ship of 300 meter means a ship will be, or the submarine will be, a ship here is acting as an prototype, and the same the model has been tested in the air in the laboratory. So ship 300 meter long, therefore it is Lp is equal to 300 meter. Okay, so Lp is equal to 300 meter, and also he has given the velocity of the air in the wind tunnel, means it is velocity of model. So velocity of model is 30 meter per second. The resistance of the model, force in the model, is 60 Newton. Similarly, he has given here also kinematic viscosity. He has given of the air is 0.012, that is mu m is equal to 0.18 stokes. Then the density of the model is 1.24, it is the air density. Okay, similarly here rho p is equal to the density of the seawater, and the kinematic viscosity for seawater he has given. You have to find the force in the prototype is missing, velocity of prototype is missing. Yes, you have to determine the velocity of the ship in the seawater, also resistance. So velocity, first you have to find velocity, then you have to find the force. So here 1:100 model means the Lp is equal to 300 meter. So you just substitute here. So here I have written LP by LM is equal to 100 by 1. The higher number always indicates for prototype. LP by LM is equal to 100 divided by 1. It is a ratio. So LP is 300 meter divided by LM is equal to 100. Therefore, LM is equal to 3 meters. Because sometimes you people will take LM as 1 meter. That is wrong. Okay, this is the useful of the ratio. So higher number always take to with respect to the prototype. The lower number indicates for the model. If the length of prototype is 300 meter, if it is 1:100 ratio, then LM works out to be 3 meter. Then you take this formula, you rearrange, because here dynamic viscosity is not given. He has given kinematic viscosity. Then you write the formula, you substitute, you get the velocity of prototype. Once you get velocity of prototype, yes, you have to find the force in the prototype also. Same Fp by Fm is equal to rho p AP Vp square divided by rho m AM Vm square. AP and AM have replaced by LP square LM square. You substitute everything, you will get, because the force of the model is given, so you can find out Fp as 22.15 into 10 power 3 Newton. So this completes the problems on the Reynolds model law. And next we'll move on to the problems on Froude's model law. Okay, so in the Froude's model law, so what is the difference between the Reynolds model law and Froude's model law? Is in Froude's model law we make use of scale ratios. Just remember all the scale ratios. Okay, so you just find out the scale ratios. You'll give the at least one quantity of the prototype or the model. You have to find the similar quantity of the other one, that is the model. If the model is given, you have to find the corresponding quantity in the prototype. If the prototype value is given, corresponding prototype model value you have to find by using the scale ratios. That's it. In 1:40 model of a spillway, the velocity and discharge are 2 meter per second and 2.5 meter per second respectively. Find the corresponding velocity and discharge in the prototype. Simple. The model value is given, you have to find the prototype. So 1:40 model means this 1:40 is the scale ratio for length. LR is equal to LP by LM. As I told earlier, higher number indicates for prototype. LP means 40 divided by 1. Therefore, LR is equal to 40, because all the scale ratios is expressed in terms of LR. The very first thing in the Froude's model I have to find is the scale ratio for length. LR value, LR is 40. So he has given the velocity and the discharge value of the model, that is Vm is equal to 2 meter per second, discharge is Qm is equal to 2.5 meter per second. You have to find the corresponding value in the prototype. We know what is the scale ratio of velocity. Vp by Vm is equal to root of LR. Okay, that we have derived in the previous session. So Vp by 2 is equal to root of 40. Vp is equal to 12.65 meter per second. Similarly, for the discharge, the scale ratio is LR to the power of 2.5. You know the value of Qm. The LR value is 40. 40 to the power of 2.5 into 2.5. You will get the value of prototype. Then a ship model of scale 1:50 is towed through seawater at a speed of 1 meter per second. A force of 2 Newton is required to tow the model. Determine the speed of the ship and the propulsive force of the ship if the prototype is subjected to wave resistance only. A ship model of scale 1:40, LR is equal to LP by LM is equal to 50 by 1, LR is equal to 50, towed through a seawater at a speed of 1 meter per second. Okay, this is 1 meter per second is the velocity he has given. It is a velocity of the model. Vm is equal to 1 meter per second. Determine the speed of the ship, velocity of the prototype, then propulsive force on the ship, that is force of the prototype you have to find. If the prototype is subjected to the wave resistance only, a force of 2 Newton is required to tow that model, means Fm is equal to 2 Newton. So first we have to use the scale ratio for velocity. Vp by Vm is equal to root of LR. Vp is equal to root 50. Then Fp by Fm is equal to LR cube. Therefore, Fp divided by 2 is equal to 50 cube. You will get the value of Fp. Okay, it looks very simple, these problems, but these scale ratios plays a vital role. If you forget this, instead of LR cube, if you put LR square, this problem is wrong. So you have to remember the scale ratios. Okay. Then the third problem, in the model test of a spillway, the discharge and velocity of flow over the model were 2 meter per second and 1.5 meter per second respectively, meter cube per second. Okay. Calculate the velocity and discharge over the prototype, which is 36 times the model size. means the prototype is 36 times the model size, means the scale ratio for length LR is equal to 36. Because higher number for prototype, the LR is directly given as 36, model value as given. So discharge QM is equal to 2 meter cube per second, VM is equal to 1.5 meter per second. You have to use the scale ratio for velocity. VP by VM is equal to root of LR, then QP by QM is equal to LR to the power of 2.5. You substitute to get VP as 9 meter per second, QP as 15.55 into 10 power 3 meter cube per second. Okay, so here finding the LR is very, very important. Then in geometrically similar model of a spillway, discharge per meter length is 1 by 6 meter cube per second per meter. If the scale of the model is 1 by 36, find the discharge per meter length of the prototype. Here the discharge per meter length he has given, means it is small q, as I told in the scale ratio, that is QM. In the model he has given 1 by 6. Then if the scale of the model is 1 by 36, that is LR is equal to LP by LM is equal to 36 by 1. Therefore, LR is equal to 36, higher number for prototype. So QP by QM is equal to LR to the power of 1.5, the scale ratio. Therefore, QP by QM is 1 by 6. You substitute as it is, 1 by 6 only, is equal to 36 to the power of 1.5. It is given at QP. So what is the changes? Discharge per meter length. If you used capital Q, it is wrong. Okay, because this LR ratio is changing, it is not same for both discharge and discharge per meter length. Next, the spillway model is to be built to a geometrically similar scale of 1:50 across a flume 600 mm width. The prototype, it is flume, FLUME. The prototype is 15 meter high and maximum head on it is expected to be 1.5 meter. This is the details. A spillway model is to be built to a geometrically similar scale of 1:50. By observing this, you can say LR is equal to 50. Okay. Across a flume of 600 mm width, the prototype is 15 meter high. It is height of prototype HP you have taken means 15 meter. Maximum head, small h, P is 1.5 meter. It is prototype details he has given. What height of the model and what head on the model should be used? That is the first one. Second one, if the flow over the model at a particular head is 12 liters per second, if what flow per meter length of the prototype is expected? Third one, if the negative pressure in the model is 200 mm, what is the negative pressure in the prototype? Okay, so first we will take one by one. First one is what height of the model and what head of the model. So LR is given as 50. So height of the prototype is given as 15. So here I have written the details. The width of the model, that is 600 mm. So it is geometrically across a flume 600 mm width. Okay. So height of the prototype is 15 meter. Capital HP, the head is 1.5 meter. Okay. You observe here. The first one we have taken here. What height of the model? So here height of the prototype is 15 meter. Okay. So it is direct scale ratio because the unit of it is meter, means it is LP by LM only the ratio. So HP by HM is equal to 50. Why 50? It is equal to LR only, because it is a scale ratio for the length, or the scale ratio for any physical quantity which is having a unit meter is LR only. Okay, remember that it is meter. So HP by HM is equal to 50. HP is 15, HM is 0.3. The height of the model is 0.3 meter. Similarly, head of the water, HP by HM, again it is 50 because the unit is also meter here, you observe. So therefore, the head of the model is 0.03 meter. Next, he has asked you to find the discharge if the flow over the model. Therefore, it is discharge. He has given model QM is equal to 12 liters per second. Divide by 1000, it is 0.012 meter cube per second. And what flow per meter length he has asked, means it is small QM. Small QM is equal to capital QM divided by width. What width you have to use? That width he has already given. Width of the flume as 600 mm, that is 0.6 meter. So here he has not asked the capital Q, he has asked you to find the small q. So in order to find the small QP, you have to find QM. But in the problem, he has given capital QM. Therefore, you have to convert this capital QM into small QM by using the formula discharge per meter. So per meter means the per unit width, that is the width of the flume, 0.6. Okay, QVM is equal to 0.02 meter cube per second per meter. Therefore, QP by QVM is equal to LR to the power of 1.5. That is QP is unknown. QVM you have found out here 0.02. Substitute 0.02 is equal to 50 to the power of 1.5. You will get QP as 7.07 meter cube per second. The last one is you have to find the pressure. Okay. So what is the pressure value he has asked? Okay, but remember one thing. So directly when you see the pressure means don't blindly put the scale ratio for pressure. You look at the unit of the pressure. Here the unit of the pressure he has expressed in millimeter, or he has given pressure head. So whenever the unit is given as millimeter or meter, you should use the scale ratio for length only, because unit is meter. If this unit is the Newton per meter square, the pressure can be expressed in terms of pressure head and also on the pressure. If it is given in Newton per meter square, then okay, if it is Newton per meter square, then you should use the scale ratio for pressure. Here since the unit is millimeter or meter, you should use the scale ratio. That's what H star P divided by H star M. I have used pressure at H star, that's it, okay, which is equal to 50 only. So negative, I have used negative, so the negative pressure head in the prototype is -10 meter. Okay, so this is the case. So whenever the unit is meter, you should use the direct scale ratio. Okay, the last one, in a 1:20 model of Stilling basin, the height of the hydraulic jump in the model is observed to be 0.2 meter. What is the height of hydraulic jump in the prototype? If the energy dissipated in the model is 1/10 kilowatt, what is the corresponding value in the prototype? Okay, so LR is given as 20. So height he has given, height of the hydraulic jump in the model, HM is 0.2 meter, HP you have to find. So if the energy dissipated of model in the kilowatt means you have to use the power is 1 by 10 kilowatt, PP you have to find. HP by HM is equal to 20. The height of the hydraulic jump in the prototype is works out to be 4 meter. Then here it is the power, you have to use the scale ratio for power, don't use the scale ratio for energy. You observe the unit, it is kilowatt. Okay, so PP by PM is equal to LR to the power of 3.5. It is PP divided by 1 by 10 is equal to 20 to the power of 3.5. You will get the power or the energy dissipated in the prototype. Okay, last problem I'll give you as an homework, or you just solve by yourself. Okay, the characteristics of the spillway are to be studied by means of a geometrically similar model constructed to a scale of 1:10. If the maximum rate of flow in the prototype is 28 cubic, what will be the corresponding flow in the model? If the measured velocity in the model at a point on the spillway is 2.4 meter per second, what will be the corresponding velocity in the prototype? Third, if the hydraulic jump at a foot of the model is 15 meter high, what will be the height of the jump in the prototype? If the energy dissipated per second in the model is 3.5 Newton meter, what energy is dissipated per second in the prototype? Okay, these are the 4 quantities you have to find here. So 1, 2, 3, and 4. Here it is Qmex for the discharge he has given. Okay, so it is LR is equal to 10 here. So discharge, you can find QP by QM. So if the measured velocity of the model in the spillway is 2.4, it is the velocity. VP by VM is equal to root of LR. Hydraulic jump, that is HP by HM is equal to LR only, unit is meter. Energy dissipated, here the Newton meter. Here you should use the scale ratio for energy. That is the scale ratio for energy is LR to the power of 3.5. He has given is Newton meter. Okay, energy dissipated, what energy is dissipated per second in the prototype he has asked. He has given Newton meter, so be careful about this unit and solve this one. Okay, thank you.